Hello guys, good evening everyone. Welcome to the session. Welcome to the India's most comprehensive preparation platform, the BYJU'S Exam Prep. Very good evening everyone. And this is the yet another class from calculus from the engineering mathematics, and in this particular class we are going to talk about the question practice. Yes, very important topic, the very important concept of maxima and minima we were learning in the last class, and we have covered up the cases and the concepts, and now we need to move towards the question practice zone, so come on everybody, quickly update your friends that the session is live. They can watch this session and enjoy the questions of maxima and minima. Very important topic, as you know this is, isn't it guys? All right. Yeah, good evening everyone. So slowly students are joining. Let everybody quickly join so that we can begin up the session. Just a second. Right, chalo, so let's get moving. So we'll be directly jumping into the question parts today, because as you know that we have already covered up the concepts, but yeah, of course through the question also the concepts will be automatically revised and brought into the picture once again, what method we learned, right? Okay, good evening. Chalo guys, in case somebody new to the session, this is a brief intro about me. This is your mentor and educator Rakesh, and I have secured all India rank 9th in the GATE examination, completed my masters from Indian Institute of Science, Bangalore. It's been more than 11 years, having trained more than 50,000 students. I usually deal with control system, signal and system, electromagnetic theory and digital electronics in the technical domain, and other than that I also deal with the aptitude and maths in the non-tech domain. Right. Okay, the Hall of Fame GATE 2022 results were out, and BYJU'S Exam Prep students have really outshined in the results in the GATE 2022 examination. All India rank 1, 2, 3, multiple ranks under 50 and many ranks under 100, under AIR 100. I hope that you are one of them in the upcoming year, GATE 23, GATE 24. I pray that your preparation is on the right track and you keep on doing all the required things for this particular examination. Right, now other than this I have some more important information for you, right? What are the sessions that are other important sessions that are going to begin for you? Just have an idea about that as well, just have a basic idea about that as well. Okay, what are the different type of sessions that is going to be there for you? So for EC guys, the very important communication systems is starting. Very important communication systems is important by Dinesh Gutha sir, and that is going to start from Tuesday. The timing will be 8 p.m. right? For EE, power systems is going to begin up. That is going to be taken by your favorite god of power systems, Ashutosh Saxena sir, and that is again beginning from Tuesday at 8 p.m. right? Since this time signal and system concepts were going on, and now we take up some concepts from communication and power systems. For computer science students, it's computer organization and architecture by Anil Prasad sir. That is going to start from today only, Sunday. This means today, because today is Sunday only. That is at 8 p.m. right? And for mechanical and civil, fluid mechanics by Chandrasekhar sir is going to be begin from Wednesday. Okay, that is again at the 8 p.m. So this is some information about the new technical subjects that is going to begin up on this particular channel. So do not forget to subscribe the channel, stay subscribed, stay learned, keep learning technical as well as non-technical session, and as well as generic sessions also we are bringing. Like last class I took up the strategy to secure all India rank under 100, how to obtain a double digit and single digit rank, what toppers usually will do. Right, now guys, let's come back to the question part. Everybody, let's come to the question and start discussing the question. Okay, I see the crowd little bit slow in joining today. Maybe Sunday they are resting, or maybe it's the IPL day, whatever it may be. Yeah, IPL or lazy Sunday. But yeah, there is some unexpected thing that I sometimes see from the students' side, isn't it? Chalo guys, answer me this question. Let F R to R, a domain is or set of all real numbers, a range is also set of all real numbers, be given by fx equal to x minus 1, x minus 2, x minus 5. Right. Define f of x, capital of f of x is integral 0 to x ft dt. Integral 0 to x ft dt for x greater than 0. Right. Which of the following options is or are correct? Which of the following options is or are correct? So now, what is this type of question you are able to see on the screen? MSQ, a multiple select question. So I have also incorporated a MSQ, a latest pattern, because especially guys, if you have noticed the gate 22 now, the number of MSQs increased in most of the branches in gate 22, and also there were, there were almost in all the branches there were MSQs which were from maths. Okay, so we have to be very careful whatever your branch may be. Next year definitely from this subject, from engineering mathematics, you can expect the MSQ. Okay, so let's say this function small fx is given and I need to consider capital Fx, and we have to see what does the question says. The question is asking about the capital F function. Where does it have the local minima? Where does it have the local maxima? Where is it increasing or decreasing? Whether it has how many maxima, how many local minima, all those things they are asking. They are asking for which function? The capital F function. Right. They are asking about which function? So they are wanting to discuss about the capital F function. So, right, to get the maxima or minima, what is the fx? It is given as integral 0 to x ft dt. Integral 0 to x ft dt. That is what is the fx function given to me. Acha ji sir. Okay. Now, what will be the derivative of this? What will be the derivative of this part? Right. Because I want to comment on the maxima minima part, so I need to have the derivative of this function. Derivative of which function? The derivative of capital F function. So, if I have to differentiate, this is an integral of some function. This is the integral of some function. So, what should be the answer? It is the integral 0 to x ft dt. So it is basically given by different Leibniz rule you can apply, na? Leibniz rule. F of upper limit, that is f of x. Integration part will be cancelled by the differentiation. We directly have to put the limit f of x, then differentiation of the upper limit by the chain rule, d by dx of x, minus, then you put f of 0, the lower limit, and differentiation of the lower limit, but the lower limit is a constant number, so differentiation will give you 0. So ultimately, what is the f dash x? Ultimately, f dash x is equal to the fx. Okay, d by dx of x is 1. Now, what is the value of fx? Fx is given in the question. So, and see, ultimately the question comes, the calculation comes to fx, but this is an indirect way of giving the data. Now, let me write down fx. It is x minus 1, x minus 2, x minus 5. Correct. Now, as I told you the trick in the last class, if you were available in the last class, see, first we learned the concept, the detailed concept, what is first derivative test, what is second derivative test, everything we learned in the detail, but then we went on in making shortcuts also using Wavy curve method, right? Can we make the Wavy curve for f dash? Wavy curve is a very powerful method which is used to solve polynomial inequalities, right? And here we have a polynomial type of function only. Okay, so what is the Wavy curve here for the fx, for the f dash function? For the f dash x, which is equal to, after solving I got that the f dash x is equal to the fx, which is equal to x minus 1, x minus 2, x minus 5, right? So what are the roots of these? What are the roots of this? Is x is equal to 1, 2 and 5, and let's make the simple Wavy curve coming up here in the picture. Let us make the simple Wavy curve, right? Wavy curve, what will you do? First of all, you will place all the roots in the ascending order, 1, 2, and there comes a root which is 5, all of them placed on the number line, and then the Wavy curve, guys, the Wavy curve always starts from the right of the largest root. Always it starts from the right of the largest root with the positive sign. It will always start from the right of the largest root with the positive sign. Okay, so let us start from here with the positive sign. And at every root it will keep changing the sign. At every root it will keep changing the sign. So this is plus, minus, this is plus, this is minus. Alternate signs. Na? At every root you just have to change the sign and always start from the right of the largest root with the positive sign. Now this is the Wavy curve for f dash x. Now where is the f dash x, negative or positive? That is clearly available in this information. Okay, now what are all the things that I can extract from here? what are all the things that I can extract from here? This is the wavy curve for f dash x. So what is the conclusion for fx? Okay, number one, it is increasing for, now increasing means the derivative of the function should be positive, na? Increasing means the derivative of the function should be positive, right? Derivative should be positive, and derivative is positive for x greater than 5 and x is between 1 to 2. So 1 less than x less than 2, or x is greater than 5. This is the portion where the fx is increasing. What is the portion where the fx is decreasing? Sir, it is decreasing when the derivative f dash, when the derivative f dash is negative, right? So it is negative for x less than 1 or x is between 2 to 5. So it is decreasing for x is less than 1 or 2 to 5. So 2 less than x less than 5. 2 less than x less than 5. ठीक है जी? Right, these are the two answers. Okay, now we are clear with the increasing, decreasing. Now let us also comment on few more important points. Look into this point x equal to 1. Okay, look into this point x equal to 1. The first derivative changes the sign from negative to positive. The first derivative changes the sign from negative to positive. Negative means decreasing, positive means increasing. Okay, so first derivative changing sign from negative to positive means the curve is decreasing, then increasing, and decreasing, it decreases to minima and then increase, na? Like that you can recall the concepts of last class. So what is this point? This is actually a local minima. This is actually the point of local minima. So this is a local minima, and at the same time this is also a local minima, because here also there is a sign change from negative to positive. So these are the 2 points of local minima. Okay, now have a look at this x equal to 2. Have a look at the x equal to 2, guys. At the x equal to 2, the first derivative changes sign from positive to negative. The first derivative is changing the sign from positive to negative, and hence the first derivative is changing sign from positive to negative, and hence it is a point of local maxima. If you don't remember, see, maths means nothing to remember, it's all concept and logic, you can say. Positive to negative means, first derivative positive means increasing, and then negative means decreasing. So curve was increasing and then decreasing. So what it happens? In the middle it reaches the local maxima. In the middle it reaches the local maxima. That's what I have mentioned here. Now this is the entire analysis just by one simple waveform, that is known as the wavy curve method. And now let's see the correct answer. It has a local minima at x equal to 1. It has a local minima at x equal to 1. Bilkul correct. Let's mark this. It has a local maxima at x equal to 2. Yes, it has a local maxima at x equal to 2. Does this happen? Yes, it has a local maxima at the x equal to 2. Correct. So this also can be marked correct. It has 2 local maxima and 1 local minima. This seems wrong, I think. Whether it has 2 local maxima? No, it has 2 local minima but 1 local maxima. So this is false. This portion is false, right? F is increasing for 1 to 2 and greater than 5. Increasing 1 to 2 greater than 5. Correct. Option number D. So what is the correct answer for the question? It is A, B, D. What is the correct answer for the question? It is A, B and D. A, B, D. Right, guys? So that's what it is. The correct answer is the A, B, D. MSQ type question. So we should be prepared. I told you, especially from this topic of maths, from in general maths, MSQs were there in GATE 22 in almost all the branches. So we can expect the MSQ from the mathematics surely. And let's go to the next question. Consider the function fx equal to x square minus 4 whole square, where x is a real number. Then the function has. Okay, then the function has. Yes, saddle point and point of inflection especially were explained Anu Ajay in the last class. Right, stationary points were also discussed. Okay, so if you want a complete concept, today we are mostly practicing question. The previous class that was there on Friday, we discussed the concept and variety of cases. Now let's come to this question. What does this question says? Fx is equal to x square minus 4 ka whole square. So what is f dash x? What is the f dash x? That becomes twice x square minus 4, and then by the chain rule you differentiate x square minus 4, it becomes the 2x, right? So the f dash x is actually 2 to the 4, 4x, x square minus 4 I will factorize as x minus 2, x plus 2, right? Now how many minima, maxima, 3 minima, 3 maxima, whatever it has. Now once again guys, either you can go for second derivative test, or you can simply apply the Wavy curve, because that makes our life simple, na? That makes our life simple. What are the roots of f dash? The roots are 0, 2 and -2, and all these roots I will sketch in the number line in the increasing order. This is the -2, this is the 0, this is the +2. -2, 0, +2. -2, 0, +2. Okay, right. -2 and 0 and +2. Okay, now the Wavy curve will always start from the right of largest root with the positive symbol. It will keep changing sign at every root. So here the Wavy curve goes. Just a second. Once again. Now it again becomes positive and then finally becomes negative. That is what is the Wavy curve available in front of me. That is what is the Wavy curve available in front of me. Now guys, we don't want increasing, decreasing. We only want how many minima or maxima. And so what is the correct answer? You can comment in this. So guys, dekho, the first derivative changing sign from negative to positive, decreasing to increasing. So this should be the local minima. This is the point of local minima. Now what else is local minima? This is also local minima, because first derivative changing sign from negative to positive. What is happening here? The first derivative changing sign from positive to negative. So it is local maxima. It is a local maxima. Okay, now just look into this and comment the answer. It has only one minima. That is wrong. It has only two minima. Yes. Three minima, three maxima to hai nahi. So what is the correct answer? It's option number B. It has two minima. Correct. RR and Amit, correct answer. The correct answer is the option number B. The correct answer is the option number B. Okay guys, let's move ahead to the next question. The correct answer is option number B, and then let's proceed with the next question. Next question, here it is. The function fx is equal to 3x power 4 minus 4x cube plus 10 has a minimum value at x equal to what? It has a minimum value at x equal to what? It has the minimum value at x equal to what? So see, minimum means of course local minimum. We can think about first of all. So dekhte hai na. So what is the f dash? What is the fx function given to me? 3x power 4 minus 4x cube plus 10. Right. So what is the derivative of this function? F dash s is 3 4s are 12, x cube minus 4 3s are again 12, x square, that should be equal to 0. Yeah, so I can take 12 x square common, then I am left with x minus 1 equal to 0. So what are the roots? X equal to 0, 0 and plus 1. These are the roots. X equal to 0, 0 plus 1. So there we have a repeated root also. And what do we know about the repeated root? Okay, in the Wavy curve method, what do we know about the repeated root? This is 0, this is 1. The Wavy curve will always start from the right of the largest root. So sir, this is the largest root with the positive sign, and it will keep changing sign. Here it becomes negative. But when it reaches the x equal to 0, which is the repeated root, so we know that at every root sign change will occur. We know that now at every root sign change will occur. So how many times sign change will occur here? How many times the sign change will occur here? Tell me. How many times will the sign change occur here? So here there will be the 2 times sign change, negative to positive, positive to negative, means eventually it remains in the negative side only. There is no sign change. Actually there is no sign change, right? Now what is the conclusion? Here the first derivative changes sign from negative to positive. So this is a point of local minima. This is a point of local minima, right? Then here the first derivative does not change the sign, right? And hence it is a point of inflection. See, if you go for second derivative test, sometimes it becomes lengthy. And most of the people are having the habit of second derivative test, right? Because first derivative they are afraid about inequalities. But I have made the inequality world so simple by introducing the Wavy curve method, because many of the questions are polynomial based. Yes, if it is not a polynomial question, then we'll have to change the approach. Okay, but yeah, most of the questions this approach is suitable. No second derivative, third derivative calculation within a single Wavy curve. My answer is seen, right? So it has a point of inflection, it has a local minima. So what is the answer? It has a minimum value at x is equal to, x is equal to 1. It has the minimum value at x is equal to 1, sir. It has a minimum value at x is equal to 1. Okay. It has a minimum value at x equal to 1. Okay, cool. Let's get moving ahead. Simply we are able to solve the question. Sir, what is the maximum value of fx equal to x cube minus 9x square plus 24x plus 5 in the interval 1, 6? Gate 2 mark question. In the interval 1, 6, that means they are asking about closed interval. Mein what I told you, they are asking about whenever the question is asking the maximum value in a total given interval, that means you have to comment on global maxima. And what is the procedure I told you? Let's revise. The detailed concept with graph, with waveform, everything we have studied. Just now we need to put down the method. So what is the method? Just calculate the stationary point. What is the f dash x? So the f dash x will become 3x square minus 9 2s 18x plus 24 and equal to 0. 3 ko common liya, so I have x square minus 6x plus 8 is equal to the 0, and then you have 3, factorizing it gives me x minus 2, x minus 4 equal to the 0, and x is equal to 2 and 4. These are known as what, guys? These are known as the stationary points, the roots of first derivative, and these are known as what? These are known as the stationary points. Now what I told you next, what was the procedure? I told you one of the stationary point can be maxima, one of them can be minima, but don't find right now. I told you one direct conclusion. Calculate the value of the function at the end points and calculate the value of the function at the stationary points. You should be able to get the answer, right? So you have to do, end point is 1, 6. So you have to calculate f1. You have to calculate f2. You have to calculate f4. And then you have to calculate f6 and come up with the final answer. Come up with the final answer, everybody. Okay, just let me also take up the calculator and quickly let's complete this. Yes guys, let's test it up. So what should be the value of f1? That is simple, 1 minus 9, this is 21, right? And you also comment what is the final answer looking into this. Now what is the value of f? Kya chahiye next? f2 chahiye, right? Okay, then we have this value should be coming out to be 25. Just keep checking the values. Then I need the value of f4. So ye lijiye, I need the value of f4, so that becomes, this is equal to the 21. This part is equal to what? Array, just a second. This part is the 21, and the next is what? Just a second. Next is 6, na? Okay. So this part is 41. Now tell me the answer. Now tell me the answer. See guys, I have not asked you the local maximum value. I have asked you the maximum value in the entire interval 1, 6, right? And what is the largest possible value in the entire, right? The maximum value is 41. If they want to discuss the minimum value, that is the 21. Right now, why I'm not bothered about local maxima, local minima here. If you want to learn more about this, just watch the previous class of Friday. Everything is discussed. How this shortcut came up, why we are finding the value at end points and at the stationary point, everything is discussed. If I go and repeat that, then we'll not be able to solve other problems. So you can just go through that previous lecture and how this procedure actually came up. And we have the next question. The real numbers x and y, with y is equal to 3x square plus 3x plus 1, the maximum and minimum value of y for x belonging to -2, 0 are respectively. Right, now once again, the maximum and minimum value in the closed interval. Right, maximum and minimum value in the closed interval means overall maxima minima, global maxima minima in that particular interval. Okay, which may be local maxima, which may coincide with local maxima, or which may be independent point also. So once again, we'll follow the same procedure, right? What is fx given to you? Y equal to fx is 3x square plus 3x plus 1. That is a gate 22 marks. See, these questions are commonly coming as 2 marks. f dash x is 6x plus 3 equal to the 0, and hence x is equal to the minus 1 by 2. Minus 3 by 6, that is known as the minus, so that is minus 1 by 2. What is f double dash x? The second, we don't want the second derivative. Now what we need to do, there is only one stationary point this time. So now what we are going to do, calculate the value of the function at the end points, f minus 2, then stationary point, and then the another end point, which is 0. Okay, we just have to calculate this value. So this becomes 3 4s are 12, then minus 6 plus 1, this part is 7, then 0 place kar denge, so this is 1, and then minus 1 by 4, so that should be 3 by 4 minus 3 by 2 plus 1. So minus 3 by 4 plus 1. So this is turning out to be 1 by 4. So what they are asking, maximum and minimum. So everything is there in front of you. Which of them is the maximum? 7. Which of them is the minimum? 1 by 4. Correct answer is option number A. Yes. Correct answer is option number A. 7 and 1 by 4. Very easy to grab these 2 marks. Okay. Very, very easy to grab these 2 marks. Very, very easy to grab these 2 marks. Just be watchful. Okay. Chalo. Coming up to the next question then. Let fx is equal to 3x square minus 7x square, 3x cube minus 7x square plus 5x plus 6. The maximum value of fx over the interval 0, 2 is. Again a 2 mark level question, and let's again solve it quickly. Fx 3x cube minus of 7x square plus 5x plus 6. So what should be the derivative of this? That is 3 3 is a 9, 9x square minus 14x plus 5 equal to 0. So you have to solve this quadratic equation. That will be minus b plus minus root over b square. That should become 196 minus 4ac minus 180 divided by 2a. So what is the value of x? It is 14 plus minus under root of 16 is divided by 2a, so that is 18. 18 by 18 1, and next is 14 by 18. Next is 10 by 18, that should be 5 by 9. These are the 2 roots. Now once again guys, just do the calculation and see what is the maximum, what is the minimum. Okay, the rest calculation part please complete it as homework. Let us not distribute our time on the similar question, because the past 2 questions were very similar to this. Just complete this as the homework. It is just like the previous 2 questions that we solved. I have just helped you in calculating the stationary point. अब आपको क्या करना है? You just have to calculate the value of the function at the end points and also at the stationary points. Increasing order I am writing the points, and then this is what you have to calculate. And whatever is the answer, it's a numerical answer time. Fill in the blank question, place the answer here. Let's go towards another question. Okay, let's go towards another question. If e power y is x की power 1 by x, now a non-polynomial function coming up. A non-polynomial function coming up. If e raised to the power y is x raised to the power 1 by x, exponential category, then y has a maximum or minimum at what point? So let me tell you guys, what should be the y? This is e power y. So to get y, take the log of x power 1 by x, but the power inside the log can come outside. It becomes 1 by x log x. So what should be the value of y? It is 1 by x log x. Y is known as the 1 by x log x. Y is known as the 1 by x log x. Now, to obtain and get the information of maxima minima, we need to of course differentiate this y. Okay, so let's come here. Y is, you can say, a log x upon x. We can apply the division rule. So what should be the dy by dx? Denominator will be squared up, and then numerator, denominator constant, differentiation of numerator 1 by x, minus numerator constant, differentiation of denominator, that is equal to 1. Right, so solving this, you are getting dy by dx is equal to x to x cancelled, so 1 minus log x divided by the x square. That is 1 minus log x divided by x square equal to 0. First derivative equal to 0. So you get 1 equal to log x. Here log x equal to 1. What is the answer you're getting is the log x equal to 1, and hence x is equal to e power 1. So that is known as what? Dy by dx equal to 0. I am getting the stationary point, but now we cannot apply the wavy curve. Please remember, now we cannot apply wavy curve because wavy curve method is only for polynomial equations, not in general. So how to solve this further? How to solve this further? To solve this further, we'll have to go to the second derivative. Undoubtedly, we'll go to the second derivative test now. Now, second derivative test, differentiation of the first derivative. So, x squared, denominator is squared, so that becomes x power 4. Denominator constant, differentiation of numerator, 1 minus log x ka derivative minus 1 by x. Minus numerator constant, differentiation of denominator is going to become x square ka differentiation is the 2x. Now, what I will do is, what should be the value of d2y divided by dx square at x is equal to e? What is the value of the second derivative at the stationary point? At the stationary point, so this is x to x cancel, so that is minus e minus 1 minus, what is the value of log e? Log e is 1 divided by e power 4. The second part is 0, you have only minus e upon e power 4 or minus 1 by e cube is the answer. What is the second derivative? Minus 1 by e cube, which is negative. The second derivative is negative. The value of the second derivative is negative. The value of the second derivative is negative. Okay guys, so the value of second derivative is negative. d2y by dx square is minus 1 by e cube, which is less than 0. Now, whenever the second derivative is negative at the stationary point, then that is a point of minima, right? So we can conclude that x equal to e is a point of local, negative, sorry. The second derivative is negative, so that is a point of local maxima. We proved this in the last class. Now we clearly understood the concept, we proved this, and just we are applying to the question now. Second derivative is negative, that is a point of local maxima. So the function has a maxima at e, not at e inverse, it has a maxima at x equal to e. That should be the correct answer. That should be the correct answer, everybody. Okay. That is what is the final correct answer. Okay, hope it is clear to all. Moving ahead to the next question. Okay, yes. So some geometrical based, application based questions are definitely expected in the topics of Maxima Minima. A right circular cone of largest volume. That can be enclosed by a sphere of 1 meter radius has a height of. A right circular cone of largest volume that can be enclosed by a sphere. Okay, the cone should be enclosed by the sphere. It doesn't move here. Just a second. Okay. First, let me draw a rough picture. The right circular cone of largest volume, that can be enclosed by a sphere. Okay. Okay, let's say this is the sphere. So the cone is enclosed by a sphere, and now let's say this is the center of the sphere. Let's say the radius of the sphere is capital R, so this also becomes the radius. Any line you can draw from the center to the circumference, that is the radius of the sphere. Let's say capital R is known as what? It is known as the radius of the sphere, right? Then let's say this is small r. That is the radius of the cone. Radius of cone means, of course, the radius of base of the cone, but the radius of sphere is actually given to me. Capital R is given to me as 1 meter. Okay. Now, What is the height of right circular cone that will have largest volume, maximum volume? So what is the height here? If you just see this picture, let us write down this. This is the height of the cone, let's suppose, right? What is the volume? First of all, largest to baad mein dekhenge. What is the formula for volume of cone? That is given by 1 by 3 pi r square h. The volume of the cone is given by the formula 1 by 3 pi r square h. But I don't know r, I don't know h. So it is a function of two variables right now, right? Can we relate r and h? Can we relate r and h? So now let me write down some points. Suppose this is the center of the sphere O. This is the center of the base of the cone, that is A, and this is a point on the circumference, that is B, right? Let's separate out the triangle OAB here. Let us separate out this triangle OAB here, and it is a right angle triangle. This is capital R, which is 1. This is small r, unknown. And what is this OA? What is this OA? Let's suppose this OA is equal to x. Let it be x right now. अब इसको हम x बोल देते हैं, right? So if this part I am calling it as x na, just a second, right? If this part I am calling it as x, so x plus r, ये भी ध्यान रखना, x plus capital R is the total height of the cone. So r का value 1 है, the value of r is the 1, so x plus 1 is the height. Okay. Now, according to the Pythagoras theorem, we have a right angle triangle. So according to the Pythagoras theorem, x square plus r square is hypotenuse square, is the hypotenuse square. Okay. Now, what should be the value of x? X is h minus 1, right? So ये हो गया h minus 1 whole square plus r square is equal to 1, right? Open up this expression. What do you have? H square plus 1 minus 2h, h square plus 1 minus 2h, a square plus b square minus 2ab plus r square is equal to 1. So 1 and 1 is getting cancelled. 1 and 1 is getting cancelled, right? Now, if 1 and 1 is getting cancelled, what should be the value of r square? See, ultimately, we want a cone which is having largest volume, and what is the height of that cone? We are interested in height. That's why I'm trying to eliminate r square. Both are unknown. So let's solve in one variable, and for that I will eliminate r square so that we have a function of only height. So what is the value of r square? 1 or 1 cancel hua. R square is looking as 2h. That is the 2h minus h square. Okay, 2h minus h square. Now what is the volume? Volume is 1 by 3 pi r square h. Volume is 1 by 3 pi r square. What is the value of r square? It is the 2h minus h square into h. So that volume is 1 by 3 pi 2h square minus h cube. Now we need to talk about maximum volume, right? And for maxima, largest means maxima, and for maxima we know that we have to go to the first derivative test, first derivative calculation again. dv by dh will become 1 by 3 pi 4h minus 3h square equal to 0, right? From here, if you take h common, 4 minus 3h equal to 0. So there are the two roots, h is equal to 0 or h is equal to 4 by 3. But the height of the cone cannot be 0, because if the height of the cone is 0, the cone will vanish. Because if the height is 0, the cone will vanish. So height cannot be the 0, right? Height cannot be the 0. So the possible stationary point that you can take is 4 by 3. Just confirm whether it is the correct maxima, because we need the maximum volume, na? So once again I go to d2v by dh square, and once I apply the d2v by dh square, what I'm going to get? So differentiating again, the 4 minus 6h, right? Now what should be the value of the d2v by dh square at the stationary point, at h is equal to 4 by 3, at the stationary point? So this is going to become 1 by 3 pi 4 minus 6 multiplied by 4 by 3. This is cancelled as 2, 4 minus 8, negative, confirming, right? What do we have? The second derivative is negative, so we can say that, so the volume of the cone is maximum at the obtained stationary point. And what was the stationary point? H equal to 4 by 3. So question में यही पूछा था ना, so it has to have the largest volume. What should be the height of the cone? The height of the cone should be 4 by 3. The height of the cone should be 4 by 3. Yes, Tushar. Theory ka video is available on Friday's class. If you want to learn the theory and concept of this topic, complete concept, Friday, 2 days back. Today, question practice. Okay. Chalo, let's move ahead. For a right angled triangle, if the sum of the lengths of hypotenuse and the side is kept constant. For a right angled triangle, क्या बोलते जा रहे हैं? Let's just trace that. Right angled triangle first of all. For a right angled triangle, if the sum of the lengths of hypotenuse and any side, let's suppose this is a side and this is the hypotenuse, right, is kept constant, then in order to have maximum area, what is the angle between the hypotenuse and the side? You can take either this side or this side. I've taken this as the base. I've taken this as the base side, right? Right. No, I don't have any such handwritten notes, Amit. Right, so this is what is hypotenuse, this is what is the side. Okay, so sum of them is constant, the sum of them. So now let's suppose this side is equal to b, isko b bolte hain as base, and this is the hypotenuse h. We are given that h plus b is equal to some constant. Okay, yeah, let's make the variables simple so as to solve the problem clearly. Okay, so we have one of the side as x and we have the hypotenuse as y, and x plus y is given to me as constant, suppose c. So we have x plus y is constant. We need what is the value of theta in order to have what? In order to have maximum area. So sir, first of all, what is the area? What is the area expression? Area is given by, for a right angle triangle, half into base into height, half into base into height. Now what should be the value for height? What should be the value for height? According to the Pythagoras theorem, height will become square root of y square minus x square, because x square plus height square is the y square. Pythagoras theorem apply kar diya just. So this is known as half into base. Base is x into height. Height will be square root of y square minus x square. But it is a two variable function, na? Okay, what is the area? Area, let's suppose area is a, and that is half x square root of y square minus x square, which is a two variable function, but we know that x plus y is some constant, so y is equal to c minus x. Let's convert everything into x. Let's convert into the single variable again. So what is the area here? That is half x square root of c minus x whole square minus x square. Right, I just need to simplify this. This becomes half x square root of c square x square 2cx x square. So x square to x square getting cancelled. What is the value of the area? It is half x square root of c square minus 2cx. Right, that is the simplified expression. That is just the simplified expression, and now I need to apply the first derivative. So what is the first derivative? dA by dx, that is half. X constant, differentiation of root x term is 1 by 2 root x first of all. 1 by 2 root x, but then by the chain rule, when you differentiate, you get the answer as minus 2c. Right, then plus square root of c square minus 2cx constant, differentiation of x will be 1. Differentiation of x is 1. Okay. So let's just try to simplify this further. So we have the dA by dx is equal to 1 by 2, multiplying throughout by c square under root c square minus 2cx, 2 to 2 cancel ho gaya hai. I have minus x into c. This is x into c with the minus sign. C square minus 2cx ko multiply karenge to under root will get cancelled. You have c square minus 2cx, then further whole divided by c square minus 2cx. But what you actually need to do, We are concerned with the maximum area, and for the maximum area we need to put first derivative equal to 0. First derivative equal to 0, so only the numerator equal to 0. What is the numerator? C square minus 3cx equal to 0. C common liya, so c minus 3x equal to 0. Right, so c cannot be 0. Right, there are two possibilities, either c equal to 0 or c equal to 3x. c 0 cannot be possible because x plus y, sum of the two sides will be some non-zero number. It cannot be 0. Otherwise, there is no triangle. Right. So, what is that you are getting from here? C is equal to 3x or x is equal to c by 3. Dhyan dena, you have got x is equal to c by 3. Right. So, we know that x plus y is equal to c. So, what is y? Y is c minus x, that is c minus c by 3, and that is 2c by 3. Okay, so what is the angle between the hypotenuse and side? So hypotenuse and side I have taken as base. So let's apply the cos theta trigonometry. Let us apply the cos theta trigonometry to complete this problem. So what should be the value of cos theta? Base x upon hypotenuse y. The base is c by 3. The hypotenuse is 2c by 3. After all cancellations, we have 1 by 2. Cos theta is 1 by 2 at theta equal to 60 degrees. So the answer for the problem is 60 degree. Geometrical application question based on maxima and minima. Correct answer is option number C, that is the 60 degree. Okay, correct answer is option number C, that is the 60 degrees. 60 degree. Cos theta equal to half at the theta equal to 60 degree. Right, everybody? Okay, so we have taken two such questions, and now let me give you one more question of geometry area to be solved with maxima minima concept as a homework, and that's a gate 2 mark question. That is again a gate 2 mark question. So this is a homework for you, right? This is a homework for you. Rest, I believe that you have enjoyed the sessions, and let me give you the important updates about the upcoming technical sessions. Once again, very quickly, for electronics communication systems by Dinesh Gupta sir from Tuesday 8 p.m. For electrical power systems by Ashutosh Saxena sir, Tuesday 8 p.m. For computer science COA, computer organization architecture by Anil Prasad sir, that is starting today only at 8 p.m. So if you are a CS student, you can start watching today. And for mechanical civil fluid mechanics by Chandrasekhar sir from Wednesday. Okay, that is at 8 p.m. Right guys, so stay tuned to the channel, stay subscribed to attend the technical sessions, the math sessions. As of now, from the calculus, around 7-8 classes I planned for you for the calculus, including the important concepts of continuity, differentiability, mean value theorems. Then we learned limits and indeterminates form. Then we learned maxima minima, and we have solved a question practice on all of this. Right. So in the upcoming time, as of now, we'll plan some more important concepts of mathematics. Okay, we can go for vector calculus maybe, or we can go for probability, or whatever is the demands of most of the students. This is the Hall of Fame, as I told you in the beginning also. The BYJU'S Exam Prep students really outside in the GATE 2022 examination with all India rank 1, 2, 3, multiple under 50 and several under 100. Right, several under 100. Yes, there will be Menti sessions for SOM and maths के लिए ऐसा plan तो नहीं किया था, but yeah, we can plan Menti. I'll plan Menti, some Menti type of session for maths, and then I'll update you. Just that's what we'll plan it in the same session, not immediately, but yeah, let me plan and execute that, so we can have a Menti for maths also. Right. So keep enjoying the technical sessions. I'll also, like signal and system was already going on for me. After that, I'll, probably take up in the technical, I'll probably take up some concepts from electromagnetic theory or digital electronic. Let's see how the team plans. But yeah, one of them, either EMFT or digital electronics, will plan for you. And in the maths or aptitude also, in parallel, I will bring you some content. Okay. So stay tuned, stay subscribed, and I hope you attended the yesterday's session also, how to secure AIR under 100, a very important strategy session, and some more session like that maybe I'll bring you in the next weekend also. Right. Okay guys, so with this, I Rakesh Sir will be signing off for the session. Hope you have liked these calculus concepts, including mean value theorem, continuity, differentiability, limits, maxima, minima. Will bring you more such concepts if you are liking. With this, I'll say bye-bye. Thank you, stay safe, and do take very good care of yourself, and stay subscribed to the channel.